Ever pondered how the sun, a colossal fiery ball, keeps burning without extinguishing? The answer lies in nuclear fusion. This is the process that fuels the sun and all other stars, a marvel of nature's energy production. Nuclear fusion, in its simplest form, is the act of two atomic nuclei combining to form a heavier nucleus. This process releases an enormous amount of energy, which is why our sun has been burning brightly for billions of years. Unraveling the secrets of nuclear fusion could be the key to unlocking a virtually limitless source of clean energy. To understand nuclear fusion, imagine two tiny particles, hydrogen nuclei, traveling at high speed toward each other. These two particles, or nuclei, are like microscopic bullets hurtling through space. They're on a collision course, and when they eventually crash into one another, we reach our first step, the high-speed collision. But wait, aren't like charges supposed to repel each other? You're right, they do. This is where the strong nuclear force enters the scene. It's so powerful that it overcomes the electric force, causing the nuclei to fuse instead of repelling each other. This is our second step, overcoming the repulsion. Now, these two hydrogen nuclei, once separate entities, have merged to form a single, heavier nucleus, helium. This is the third step, the formation of a heavier nucleus. But here's where the magic happens. The mass of this new helium nucleus is slightly less than the combined mass of the two hydrogen nuclei. This mass difference doesn't just disappear, it gets converted into energy. And this isn't just any amount of energy, it's a massive amount, determined by Einstein's famous equation E = mc2. This is our fourth and final step, energy release. So in a nutshell, nuclear fusion is the process of two light nuclei coming together to form a heavier nucleus, releasing energy in the process. Now that we've delved into the process of nuclear fusion, let's summarize the key points. Nuclear fusion, in a nutshell, is the process where two light atoms combine to form a heavier one, releasing a gargantuan amount of energy in the process. This is the same process that fuels our sun and all the other stars in the universe. The beauty of nuclear fusion lies in its potential as a clean, efficient, and virtually limitless source of energy. Unlike fossil fuels, it doesn't contribute to greenhouse gas emissions, nor does it produce radioactive waste like nuclear fission. The fuel for fusion, hydrogen, is abundant on Earth, and a small amount can produce a colossal amount of energy. But the challenge is replicating the conditions necessary for nuclear fusion right here on Earth. It requires extreme temperatures and pressures, akin to those found in the heart of a star. Nuclear fusion is not just a marvel of the cosmos, it's a beacon of hope for our energy future. Harnessing its power could be the answer to our energy woes.